Hi, everyone. Welcome to the webinar, Gaining Competitive Advantage Through Modern CAE Technologies, where we will discuss the key factors of a robust HPC and simulation system and dive into how on-demand compute is suited for today's manufacturing needs and how to realize new levels of performance, cost reduction, and control with Azure HPC on Rescale's control plane. My name is Jolie Hales. I'm with Rescale, and I will be your moderator today. So our first presenter is Nidhi Chappell, who is the head of product, specialized Azure Compute at Microsoft, and she will talk about driving innovation with Azure HPC. A little bit about Nidhi. She leads the HPC and AI product team for Azure, and her team is responsible for all HPC and AI hardware offerings, including Intel and AMD CPUs, GPUs, FPGAs, and other accelerators, as well as HPC software offerings like Azure Batch, Azure Cycle Cloud, and HPC Pack. Her team focuses on bringing true HPC capabilities to cloud to enable easy on-ramp for tightly coupled HPC and large-scale AI jobs. Prior to joining Microsoft, Nidhi was at Intel for 12 years, where she led the development of AI product strategy and Intel's efforts around converged workflow for HPC and AI. Nidhi holds a master's in computer engineering from the University of Wisconsin and an MBA from the University of Michigan, and holds a U.S. patent on branch prediction. After Nidhi, we'll hear from Carl Podesta, who is an Azure HPC technical specialist at Microsoft, and he'll walk us through Azure HPC discrete manufacturing. A little bit about Carl. He is a technical specialist for HPC on Azure. He is part of Microsoft's Global Black Belt team, which is a specialist team that is focused on advanced workloads in Azure and dedicated to focus on working with customers throughout the EMEA region. He brings specialist HPC industry experience from oil and gas, financial, academic, and health domains by working on related POCs, pilots, demos, presentations, content, and customer engagements, and he focuses on supporting colleagues, customers, and partners to help shape the future of HPC in the cloud. After Carl, we will hear from Bernardo Mendez, who is a solutions architect at Rescale, and he will show an intelligent full stack approach to HPC for manufacturing through the Rescale control plane. A little bit about Bernardo. He has a master's degree in computer manufacturing and a 13-year background working with CAE tools in the automotive industry, first as a chassis development engineer and later as a technical specialist in hardware in the loop systems and multi-body dynamics applications. He enjoys helping customers unleash the full potential of HPC in the cloud through his work at Rescale. Okay, at this time, I will go ahead and turn this webinar over to Nidhi from Microsoft. Nidhi, take it away.
Hello, my name is Nidhi Chappell, and I lead the product and engineering team at Azure HPC. Today, I'm excited to talk to you about how our customers use the power of Microsoft Azure HPC to unlock their innovation. High-performance computing, or HPC, spans many verticals: automotive, financial services, energy. Basically, a lot of our customers use modeling and simulations, whether it is customers in the automotive space that use simulation to model all aspects of automotive engineering, or customers in the financial services that use risk modeling to understand their exposure to the capital markets, as well as meet the regulatory requirements, or customers in the energy space that are using the latest techniques in the upstreaming process. Across all of these verticals, our scientists and engineers are always at the frontiers of science, and they're always looking for performance and performance at scale. With these requirements, we have designed a cloud offering specifically for high-performance computing. Unlike some of our competitors, where you have to take your high-performance computing and fit it to a vanilla cloud, we actually offer purpose-built infrastructure that is optimized for HPC workloads. And we offer the latest and greatest CPUs from Intel and AMD, and the latest and greatest GPUs from NVIDIA and AMD. Our goal is to offer the latest and greatest technology, time to market with these vendors, so our customers can have the best performance in time. Not only are we optimizing for compute, but we understand that for HPC performance, you have to have a balanced InfiniBand network as well as a balanced storage infrastructure. In fact, we are the only cloud service provider that had 200 gigabyte HDR InfiniBand working before any of the other OEMs had it working. Beyond just that, we also offer a wide range of storage requirements to meet all sorts of customer requirements. Our goal is to make sure we can deliver the promise of cloud, performance, and agility on end-to-end flows. We do this by making sure that our customers can take their known and familiar tools and be able to orchestrate their on-premise workflows into the cloud. Beyond just the HPC workflows, nowadays, customers are also looking to augment HPC with AI to add more intelligence to modeling and simulations, sometimes even to augment modeling and simulations. This is where Microsoft in-house AI capabilities are also being used. As we look to deliver the next generation of HPC, we truly believe that the world of HPC and AI is coming together, and we at Azure can uniquely deliver performance intelligently at scale. In fact, we are the only cloud service provider that has showcased performance at scale. Recently, we published performance that showed 80,000 cores, one single job, one tightly coupled job running across 80,000 cores in Azure HPC. Our customers have pushed the frontiers even further. One of our customers in Europe actually delivered 1 billion cell models on Azure HPC. Beyond all of this, we are constantly pushing what we can showcase. And with AMD, we actually now can deliver 45% better memory bandwidth than most of our on-premise customers have today. What this means is for memory-bound applications, they will see much better performance and much better cost structures. As we look to improve the performance of our infrastructure, we have made significant investments in making sure everyone in our value chain, be it pre-sales, sales, product marketing, product engineering, or even post-sales and customer support, everybody in this value chain has deep HPC and AI expertise and has worked in this space for a long time. This unique combination of Microsoft's investment in infrastructure, as well as our deep expertise in the workload itself, means we can actually uniquely deliver a product that nobody else can. Beyond just delivering a product, we do believe that we need to bring the ecosystem along for our customers to be able to realize the performance. This is where we have been enabling a rich HPC partner ecosystem. We truly believe that our success will come through our partners, not by going around them. We've made significant investments in all the schedulers, in OS development, in Linux, in MPI applications. We actually work very closely with all the top ISVs. In fact, Azure is the #1 choice for all the ISVs for trying to provide a curated HPC experience in the cloud. Beyond just the ISVs, we also have a lot of partners that we work closely with, whether it's Rescale, whether it's Snag. We want to make sure for our customers to have a seamless experience. They can take their software stack that they have optimized arduously over the last few years. They can take that same software stack into the cloud and have that run seamlessly. We live in unprecedented times. With the pandemic spreading across the world, HPC has been rising to the challenge again. Our scientific community has been working very hard globally to find a cure for this. And we've been working very closely with them, whether it is through the HPC Consortium or Microsoft's own investment in health grants. We've been working to provide HPC infrastructure for a lot of the scientific communities so they can accelerate their research. One example of that is the research community at Duke University. Let's listen from Dr. Amanda how she was able to use the power of Azure HPC in accelerating her research.
So this all started very early on in the entire pandemic. You heard in the news every day that there was a need for more ventilators. One of our colleagues wanted to create a device to help improve ventilator capacity in splitting ventilators between two patients. To do that, we needed to run hundreds of millions of simulations that in total required almost 1 million compute hours. We applied to the COVID-19 HPC consortium, and then they paired us with Microsoft AI for Health. They pulled in experts, and they figured out everything we needed for the infrastructure while letting us focus on the science. By Monday morning, we had completed 800,000 compute hours and finished the entire job within 1 week of submitting the application. We used the Azure Cycle Cloud platform because it allowed for dynamic, resilient computing. We were able to get 800,000 compute hours over a weekend. It was pretty amazing to be able to submit for FDA approval less than a week and a half after requesting the compute time. We hope that having a device like this will allow physicians to have a safer way for making these difficult decisions.
That was a really heartwarming video. All of this is possible because Microsoft has made significant investments and remains very committed to HPC. Technology in the cloud is changing rapidly. We want the promise of cloud, scalability, agility to be available to everyone. And that is why Microsoft is making significant investments, whether it is in IoT, in AI, in HPC, in quantum, so that our scientific community can actually deliver applications that are ready for the future. Ultimately, the developers for the HPC applications want to use the tools that they are familiar with, the application stacks, the schedulers, the MPI libraries that they are familiar with. And this is where we take the existing stack and enable it on Azure. So you can actually continue your development on the tools you're familiar with. We want our customers to be able to use the same experience, whether it's on the edge, in your own data center, or in public cloud. As you run your application through all of these, we want the experience to be seamless. And that is why we make significant investments in all these areas. Last but not least is trust. Trust is very important, especially in the context of public cloud. Microsoft has made significant investments ahead of the curve here. We invest $1 billion every year and have 3,500 cybersecurity engineers constantly looking to mitigate the threats in this space. When it comes to compliance, we are number one. All of these investments in Microsoft, in Azure, in Azure HPC are to make sure that the promise of cloud, performance, and scalability can be available to all of our customers. Thank you so much. I hope you found this talk interesting. Here are some more links in case you're interested to explore more. Thanks, and have a good rest of your day.
Thank you so much, Nidhi. Some really interesting information here. And this time we will turn it over to your colleague, Carl from Microsoft, to walk us through Azure HPC discrete manufacturing. Take it away, Carl.
Hi everybody, I'm Carl Podesta. I work as a high-performance computing technical specialist for Azure, and I'm happy to have you with me today to listen about some of the challenges our customers in manufacturing and engineering experience and how we can address some of those challenges with our platform. So manufacturers are being asked to visualize real-time product and product performance from anywhere, and that goes to our situation now with COVID-19, and many of us are working from home, and the expectations are still on us to work as we have been doing before from anywhere. We also need to understand what's happening more with physical products and use things like digital twins to really understand what could happen in those products and to really optimize the products a lot better. We also need to incorporate feedback from IoT, so devices that are now everywhere and information that's coming and data that's coming from those devices. We need to incorporate that data into the simulations and into the work that's happening so that we can develop better products and understand real world effects into the products that we're going to design and improve. And all of this is being asked to happen a lot quicker than ever before. You need to do this faster. But challenges can really hamper our ability to do all of that. So We typically are working with some sort of fixed system. We have a workstation under our desk. We have a bunch of computers in a server room somewhere. And it's been an investment that we've made, but suddenly a new workload has come in and we need to do it faster than we need to do it before. We don't have the capacity to do it. And it's an opportunity that's been missed. And then other times, maybe the work has not been as busy as we've expected it to. So a number of projects happen together. They often finish together. And then some of the resources that we've made the investments in are just sitting there not being used. Again, another missed opportunity. And again, how do we collaborate better amongst all of this with our colleagues spread across the world, spread across different locations? So we've really got a geographical disparity here going on as well. All of these obstacles together really make it difficult for us to be able to do our work. So in addition to those challenges, transformation of our business is also requiring a next level of computing power. So some of the items that you're seeing on the slide are really illustrating how we have more data than ever before, how we will have more data than ever before, and how we're also expected to learn and incorporate that data into the simulations and into the work that we're trying to understand. So we believe that that transformation can also happen through simulation. This is a real opportunity, especially with the cloud, for us to bring simulation to everyone, everywhere. And that means that we can also enhance the traditional factory type of mode that we're doing, the traditional products that we're developing with these new digital capabilities. We can really develop new products on top of that and monetize on the back of that as well, thus creating new value, new business for us. And this is also what the transformation is really about. So combining high performance computing and simulation with all of the other capabilities of the cloud, including IoT, artificial intelligence, and machine learning, this is the opportunity that we all have. So thinking about the engineer's workflow, we might start off using a workstation where we have to develop the product initially, to do some pre-processing, to develop a 3D model and interact with it. Then spinning off to a simulation or an analysis, or multiple simulations or analysis that may even take many hours, many days to do. And then we're coming back maybe to the workstation to analyze the results of that process. Maybe after all of that has been completed as well, we're then moving on to developing product brochures for that. So maybe doing some rendering of what the final product may look like and publishing images for customers or colleagues to look at alike. But how about integrating deep learning, machine learning, or artificial intelligence techniques into that? So what about all of the data and all of the simulations we've generated? Are there smarter ways to do that? And could machine learning really help us? Integrating that into the workflow that we've just described is part of what can be done together in the cloud. So how can Microsoft and Azure in particular help some of this transformation? Well, it's different in terms of providing on-demand, extensible, and scalable resources to aid that transformation. And all of this together with unique capabilities that fits in Microsoft Azure. So when we talk about being on demand, you want to be able to scale up that compute and simulation power when you need it, as much as you need it, wherever you need it. You also want it to be extensible. So you want it to complement the investments you've already made in systems on premise. Maybe you only need this power for a particular project or a particular simulation at a given time, and not for the rest of the year. Another capability is it being scalable. So you really want it to be able to scale up and down easily. The whole thing has to be easy to do, and it has to leverage all of these advanced technology capabilities that we have together in Microsoft Azure. And that includes at the operating system level, at the hardware level, at the application level, and of course through our partnerships and vendor ecosystem that we work closely with. So here's a suggested path that you might be able to take to make this happen. So one of the things that you can do to get started is to simply lift and shift or clone to cloud. And that involves taking applications or data that you've already got, spinning up some resources in the cloud and getting them done in that manner. So this can already bring some benefits to you in terms of geographic reach and scalability and choosing the type of machines that you want. And this really works for some of our customers as things stand. Then as you start to develop things a bit more, you may really need to leverage the existing investments you've made, have a hybrid workflow that encompasses storage, compute capabilities that you have already developed in your site, and really expanding those to the cloud as part of a whole workflow. You can go one further and really do the whole workflow in the cloud, and that includes pre and post processing workstations, multiple machines to run the simulations, and capabilities such as machine learning, IoT afterwards to be able to develop and leverage more value from the simulations that you've done. And Finally, you can also leverage unique capabilities in Azure to do cloud native style workflows. So really, it's about choosing the right workflow for you, for your users, for your situation. Let's take a closer look at one of our compute offerings specially designed for HPC. The Intel Xeon scalable processor, codenamed Skylake, used with the Azure HC series, is designed to meet the demanding requirements of HPC in the cloud, along with pre-installed and configured tuning management software. Users can take advantage of a common code base across on-premises and public cloud infrastructure, including Intel hardware acceleration technologies like AVX512 and common HPC management and optimization software. You can have confidence that all of the Intel components you'll use are optimized for maximum performance, and that includes storage, interconnect, compute, and memory. Beyond the hardware components of compute, storage, and networking, there's unique capabilities in Microsoft Azure to be able to leverage these in an easy way. Two tools that we're highlighting today that are also free to use are Azure Batch and Azure Cycle Cloud. And these are both methods you can use to automatically create clusters and machines together in the cloud, turn them on when you need them, turn them off when you don't need them, and to do so automatically. So whether you prefer to interact with this through code or whether you prefer to have a nice interface to be able to do it that you can share with users who are unfamiliar with using the cloud but familiar with using clusters and workstations, then these are two tools that are a great choice that you can also integrate with your workflows. Microsoft Azure is built for HPC. Only Microsoft has all of the pieces of the puzzle to fit together to help you in your journey to the cloud, wherever you may currently be at. This includes a comprehensive portfolio of capabilities: compute, storage, networking, infrastructure as a service, platform as a service, software as a service, and supercomputer style capabilities to meet your simulations, whatever scale. We also make it easy to transition. So we have a number of native tools to make it easy to spin up these resources, to put them together into workflows that includes hybrid capabilities with your on-premise investments. We also have intelligent cloud capabilities. So you want to join and combine high-performance computing with AI, machine learning, and IoT, really to leverage the value that the cloud can bring by combining these solutions together. We have an extensive partner ecosystem, including our partner Intel, who we've highlighted here today. And finally, it's the investment in HPC. And this includes at all levels of Microsoft, from engineering, customer support, sales, development, to really go all in on HPC in the cloud. Azure is productive, hybrid, intelligent, and trusted. We hope that today we've helped you understand some of the challenges that manufacturing and engineering customers have and how we're able to address those with Azure and Azure High Performance Computing Solutions. Thanks for listening. Thanks for your time. Take care and hope to see you soon.
Thank you so much, Carl. It's a pleasure to have both you and Adi here with us today from Microsoft for this webinar. And next, we're going to hear from Bernardo Mendez, a Rescale solutions architect who will show us an intelligent full stack approach to HPC manufacturing by way of the Rescale control plane. Go for it, Bernardo.
Thanks, Jolie, for that introduction. And thank you to Nidhi and Carl for those great presentations. Now, in this case, I'm going to take this time to talk about how Rescale and our intelligent platform is helping our customers focus on what matters the most, which is their products. And in the context of innovation, right, within the manufacturing space, we are seeing a transformation in the development process. We are coming from seeing what used to be a linear and typically long cycles that started right from the requirement definition all the way to implementation and a final product, to now what it's becoming an iterative process. And this is mainly caused because at the end where we have now this product, there's a lot more feedback that we're able to get. For instance, with smart devices, right, or IoT sensors that are now providing us additional information once the product is out in the market and used by your customers. which then allow us to, rapidly define new requirements from that moment, and a new iteration is defined, starting what's going to be the next version for that product. And of course, this also comes with the fundamental changes in the economics of it, impacting three main resources: people, software, and hardware. And then the question becomes, how can we optimize what would be the most valuable resource, right? The people, and making sure that they don't have to face the constraint of a fixed hardware asset. So this is where Rescale can help you. And we do this by providing a turnkey solution that pretty much aims to unleash flexible and virtually unlimited hardware resources in the cloud. And our platform has now close to 600 applications that are already tuned and configured so that they can leverage all the infrastructure and capabilities that Azure has to offer. And in this context now, we then ask, well, why intelligent platform, right? And what does intelligent compute even look like? So it is intelligent because first, we continuously optimize our hardware and software to deliver cost savings. And we do that by always looking for performance improvements and automating that process and bringing it to your hands to make better decisions on how to achieve these savings. We also provide an environment that you can manage and control at any scale, whether you have a small team of analysts or multinational organization with business units collaborating across the world. And finally, we also aim to simplify the technology and services available on the cloud to ultimately accelerate your productivity, and making sure that all that capability and new services that become available are working basically for your needs and consumable in an easy approach. So with that being said, then we also have to look at how our platform is being used. And I'm going to show you a brief demo that is going to take you through that process, starting from the user interface and how engineers and researchers alike can easily define their simulations and be up and running in literally just a few clicks. And also how our admins, right, HPC admins and management can keep control of the environment, right, and monitor all of the activity that takes place within their infrastructure. And we have different capability, including budgeting, including dashboarding, that's going to give you tools to have those controls to what makes sense, in this case of your economic resources, but also security and making sure that nothing happens without you knowing. So with that, I'm going to switch now to our environment. And in this case, this is what users are first going to see when they log into our platform. And this is not the only way to interact with Rescale. Rescale is built on top of our API. So we have users that also can leverage the command line interface, for instance, to submit their jobs to cloud. Now, defining a job is very easy. We're going to go ahead and click here under the new job. And we're going to see that now we have this interface guiding us basically through the steps to define it. We basically have to define three things: inputs, software, and hardware. And with that, we'll be able to submit our job. So it's always good housekeeping, though, to name this job. So in this case, this is going to be a star CCM job. So I'm just going to give it a generic name, keep it simple. And then we're going to define our inputs. Now you have the ability to, of course, upload your files directly from your computer or leverage other storage devices. In this case, I already have my files in my cloud storage. So I'm going to choose this B787 simulation file, and then I can move on to the next step, which is choosing my software. So in here, you'll see the list of 600 titles that we have already available in our platform. And if they're listed here, that means that they have already been tuned, as I mentioned before, and set up to run in the hardware. So this list can also be customized, and of course you don't have to see the 600 titles all the time, right? We would enable then in your environment only the applications that are meaningful to you. So I'm going to go and look for star CCM, and then you have also the ability to choose the version that you need. We at least carry the last 3 years of versions for each of these products, but in most cases a lot more. If there's a specific version or build that you need, we can certainly load it to our environment. And then in terms of defining the command that will be executed by the solver, we also try to make it super easy. For instance, in this case, our autofill capability, where users only need to choose the input file that they're going to be running, and that's it. The command gets already populated to do that. So then the next step would be to define the hardware. And in this case, now you can choose pretty much any VM from the Azure offering, including the latest editions, for instance, the HC series or the HB V2 series, which are very dense and robust architectures that offer tremendous scaling for CFD applications like this one. So once you choose then the hardware, you can then move to picking the number of cores that you want to leverage for this run. So with that, then you're good to submit your job. And then I'm gonna fast forward a little bit. I have a job that I have already started just to show you what it looks like now that a job is running. And in this case, once it's running, now you're gonna have a live tailing window that is going to allow you to pick, for instance, the log files, and you can monitor the progress of your simulation. But also in this case, and more interestingly, if you have plots or images that are being generated as well as the process goes forward, you can click on them and visualize them directly through your browser, right? In this case, we're looking at the residuals, right, of this run, making sure that everything is converging as expected. And of course, we also have contour plots, right? Streamlines now around this plane. So once the job is completed, now we can also choose to post-process in the cloud, right? We can validate that our runs are completed, the way we want it, and that, we can validate basically that the run is what we wanted. And we do that using our desktops. So in our desktops, we already have, pre-built configurations in which in a similar fashion, you can choose to load any application that you want and then load the jobs, right? Or load the files that you want to work on in the cloud. So in this case, I'm just going to choose this desktop and connect to it. And you can do that directly through your browser, or also if you have a desktop client. But most of our users choose to do it in the browser. It's just easier. And within this environment, it's pretty much like being in your laptop or workstation. We now have a Windows session, and in here we have loaded now this 3-car crash example using LS-DYNA, and we can animate it, or we can validate, right? The results, look at some plots, all directly leveraging the cloud. So you can see that for a user, right, it only took us a few clicks to define our job and get to the process of even looking at the results. Now, what capability do we have available for our admins and managers, as I mentioned? So for that, we have built pretty much an entire portal completely dedicated to that purpose. And I'm just gonna show you, our dashboards, right? Give you a glimpse of what's available in here. And dashboards are a new addition, right, to our environment. And the first one here is the organization overview. And in here, admins will be able to pretty much monitor and keep track of everything that happens in their cloud. And not only that, they can also leverage custom environments within their organization, which we call workspaces. So in this case, for instance, you can see that we have a few different workspaces for each of the departments in this company. One for the electric team, one for the automotive, one for the gas diesel, for instance, talking about, in the transportation manufacturing business. And each of these workspaces can have their own tools, their own hardware selection, their own billing, their own budgets, right? And that just gives you the additional capability that each organization can have their own controls, but still being under a single environment that it's easy to monitor all across. Then another one, of course, talking about economics, is this economic dashboard that will allow you to pretty much know the status of your funds, right? Where is my money going and how much do I have left? But also keep track of budgets that you can implement for these different projects or these different departments. And at all times, you'll be able to know how these funds are being used and how are they being consumed by the different teams. And the last one that I'll touch on is the security dashboard. So in this one, you'll be also you'll be able to pretty much keep track of all the activity that happens in your account, including login attempts, where are people accessing from around the world, and of course, right, how many or what security controls you have in place, including multi-factor authorization, or perhaps if you have single sign-on enabled with Active Directory, which we can support. So a lot of capability built in to make sure that this resource is implemented, with all the controls and capability that you need to make sure that you stay on top of things. So with that, I'm gonna go back then to my slides and close by saying, well, just in summary, why Rescale, right? Well, we believe, we not only believe that we have, the best technology built in our platform and in the capability and some of the features that I showed you today, but also our team is made of HPC and application engineers that truly understand simulation and the challenges that you face on a daily basis to help you out throughout this process. We try, to, pretty much, do the heavy lifting, bringing you, the cloud, so and the power that it has to offer, so that you don't have to, right? And making sure that again, right? You remove the blockers for pretty much being able to, in this iterative development process, being able to deliver the products that you need in an easy and faster, more productive approach. So with that, I just want to again thank you for your time and thank you for joining our webinar today.
Thank you, Bernardo. That was great. Really good stuff. And thank you again to Nidhi and to Carl for the information you presented here today. And that's going to do it for this webinar. And we'd also like to give a special thank you to all of you out there for joining us today. So have a very happy holiday season and stay safe.